BCIT Engineering Materials Charpy Impact Test. The objective of this lab is to measure the impact resistance over a range of temperatures for two materials, low carbon steel and aluminum. The Charpy Impact Test is a way to measure a material's ability to resist impact loading. The most common impact test specimen is called the Charpy bar. You'll be using low carbon steel and aluminum bars. They're 55 millimeters long, 10 millimeters square, and have a 2 millimeter V-shaped notch on one side. Both metals will be tested at 7 different temperatures from -79 to 100 degrees centigrade. The way the test works is the Charpy bar is supported on an anvil and then hit from behind with a hammer blow. With the notch facing away from the hammer, it will always fracture at the center, which provides a standard result. The Charpy Impact Test apparatus consists of a pendulum hammer that once released will swing down and break the Charpy bar. The amount of energy required to fracture the specimen will be shown on the top dial. This is the apparatus you'll be using in the lab. Here the hammer has been raised to the ready position. The release mechanism will drop the hammer and the indicator will point to the impact reading. It's important to remember that at the start of the test, the indicator is pushed to the left. Below is the Charpy bar on the anvil. The notch is facing away from the hammer and it's been centered. Here's the full Charpy Impact Test. The indicator is pushed to the left and then the hammer is raised and locked into position. A Charpy bar is retrieved from one of the temperature baths and placed on the anvil. To maintain the temperature, no more than 10 seconds is allowed from when it's been removed to the point of impact. The release mechanism is then pushed to drop the hammer. It took 42 foot-pounds of energy to fracture the sample. The amount of deformation after fracture will vary depending on the material and the temperature. Test data is recorded on a table of temperatures for both materials and then plotted on a graph of impact resistance versus temperature. As you can see, the impact resistance of one of the materials is fairly stable. The other material exhibits low energy fractures at low temperatures, and then there's an abrupt transition to higher energy fractures as the temperature increases. In a country where it regularly drops well below zero, it's a good thing to know when choosing materials for construction or manufacturing.